Assalamu alaikum everyone. In today's video we are going to solve exercise 3.4. I will solve selective question of this exercise. So let's discuss theorems first. There are many theorems in this exercise related to proportion. Please go through them one by one because we will only discuss the most important theorem of this exercise. First is theorem of invertendo. Invert means you need to change the values. So that's why A ratio B is equal to C ratio D. Then B ratio E is equal to D ratio C. We have just changed the places of B and A. So please go through all these theorem. Theorem of componendo, theorem of dividendo. But the most important theorem of them all is theorem of componendo dividendo. So you can write it with the keyword CD. So Componendo dividendo theorem says if A ratio B is equal to C ratio D, then A plus B ratio A minus B is equal to C plus D ratio C minus D. Or you can change the values places and you can say A minus B by A plus B is equal to C minus D by C plus D. If you are writing plus sign on the top, so you will use plus sign on the both sides of the proportion. If you are using minus sign in the denominator, so use minus sign in both denominators. So that is the most important theorem of this exercise. Now let's solve questions. Question number 1. I have picked two parts, first part and sixth part. So if you need to prove that A ratio B is equal to C ratio D if the given values are equal. So using componendo dividendo theorem, now this is very important. 4a plus 5b, this whole term is considered A, and 4a minus 5b, this whole is considered B. So same is the case with 4c plus 5d is your C, and 4c minus 5d is your D. So using componendo dividendo theorem, we will write down A plus B by A minus B is equal to C plus D by C minus D. So I have opened the brackets and cancelled the terms which are making 0 pairs. So I am left with 8a by 10b on left side and 8c by 10d on right side. I can take out 8 by 10 from both sides. I can cancel it. So I'm left with a by b is equal to c by d. So which is proved. That's what we need to prove in this question. Moving on to question number 6. That was a different question. In between all the parts are similar. So in this question you can see there are 4 terms in the question. A plus B plus C plus D, this whole is considered A. So applying componendo dividendo theorem, so you will write down A plus B by A minus B is equal to A plus C plus D by C minus D. So there are 2 things you need to be careful of. First, you need to be careful of signs so that you can cancel the right terms after this step. And second, please write them very clearly so that there is no confusion. It is B or D, C or A. So now the leftover terms are 2A plus 2B and 2A minus 2B by 2C minus 2D. So cancelling all this. So in this question, this is why this question is different, because we reach to this situation A plus B by A minus B, C plus B by C minus D. So we will apply the componendo dividendo theorem again. So we will apply again this theorem on these values. So then we again simplify it and we will get A ratio B is equivalent to C ratio D. Moving on to question number 2, which says using componendo dividendo theorem, you have to find value of the given expression if x is equal to this. So in this type of questions, we will use the value x, the given value of x, and we will form the both parts of the expression, x plus 2y by x minus 2y, as well as I will find the value of x plus 2z by x minus 2z. How I am going to find these values? I will be using this given value of x. So since x is equal to this, now I'm splitting the denominator into 2 parts in such a way that one part is same as the first part of one part is 2y. Why I'm changing it into 2y? because I need x and 2y on the left side of the equation. So this is the new formation. Now I will apply Componendo Dividendo Theorem. So when I will apply the theorem, I will get, now you can see left hand side is the same as the one given in the question. So I will solve the right hand side and I will call it equation 1. So why we are doing it? Because later on we will put the value of x plus 2y by x minus 2y into the given equation which is in the question, so that we can solve and prove the value of x. So I hope this is clear. There is one mistake in this paper. I have written Exponendo Dividendo Theorem, whereas it is Componendo Dividendo Theorem. So moving on to the next part. Now I have used the given equation, given value of x again, but this time I am splitting the required y value, so that my other form of the second part of the equation is also found. So x by 2z is equal to 2y plus y plus z. So by Componendo Dividendo Theorem, I will apply the theorem, I will write it down, and I will conclude this equation x plus 2z by x minus 2z is equal to what? So now I need to add the two equations so that my left hand side is same as the one given in the question, and I will resolve my right hand side now. So denominators are different only if I take negative common, so the denominators will become same. So I will do that. I will take LCM and then I will solve the equation, and I have reached that this is equal to 2. So I have found the value of the expression using value of x. So the similar method I will use again. So using the value m is equal to 10 n p by n plus v. Please go through this question. It is the same method. First we will find the value of m plus 5n by m minus 5n. So using the given value of m. So we will call it equation 1. Then we will use the value of m again, and we will found the expression m plus 5p is it by m minus 5p. So then we will call it equation 2. So then we will add equation 1 and equation 2. When we will add the two equations, the left side of the equation is same as the expression given in the question. So now we need to solve the right part so that we can find the value of the given expression. So again the denominators are having thus the difference of sign. So I will take sign common. So if I take the sign common, you can say my LCM is same now. It is p minus n. So I can take p minus n LCM, and the remaining terms will come on the denominator. I will combine the like terms. 3p minus p is equal to 2p. Take out 2 common, and p minus n will be cancelled. So the value of the given expression is equal to 2 again. So moving on to sixth part, because this is a different part. Rest of the parts before 6 are the similar parts, just like we solved first and second. So you can do it on your own. So sixth part is that you need to solve this expression. So we will apply Componendo Dividendo Theorem. Now my whole A is the expression given on the numerator, and the whole B is the expression given in the denominator. I will apply the theorem, I will simplify, and then I will take square root. So after that I will get two values of square root, which is plus minus 5. So I will solve them separately to get two values of x. So this is very important. If I will not take the square root on that moment, and if I open the square values using the formula, so then the question will become very difficult. So solve the rest of the parts of this exercise using the same method. So I hope you will be able to solve them easily. That's all in today's video, everyone. Thank you for watching. See you in the next video. Allah Hafiz.